All right, chapter 9 is all about scientific notation. In this section, we are going to talk about what scientific notation is. So first, we are going to use this table right here to determine if these statements are true or false. So let's start with this top one. As the exponent of 10 increases, so the exponents of 10 right here, we're going, as the table goes up, the exponents increase, the number becomes greater. Well, let's look at the number. As it goes up, it looks like these numbers are getting bigger. So this is, in fact, true. As your exponent goes up and gets bigger, so does the number. So when you start comparing these numbers, the bigger the exponent, the bigger the number. Next, a negative exponent of 10 makes the number negative. So here's a negative exponent of 10 right there. This number is not negative, so this is in fact false. It makes the number smaller. It does not make the number negative. 5 times 10 to the third is right here, is greater than 5 times 10 squared, which is right here. So it's saying that 5,000 is greater than 500, which is true. 5 times 10 to the negative third is greater than 5 times 10 to the negative 2. Well, 5 times 10 to the negative third has more zeros than 5 times 10 to the negative 2. Therefore, it is not greater than, it is less than, and this statement is false. So order the following numbers from least to greatest. This last one, we're going to put times 10 to the 0, just to help us out. Now, like I mentioned in the previous example, when we are ordering these numbers or putting them in order of comparing numbers, the bigger the exponent, the bigger the number. So if we're going from least to greatest, we're going from smallest to largest. We got to pay attention there. We want to start with the smallest number. Well, let's look at the exponents here. I want to go with my smallest exponent, which is negative 2. So that is my smallest number. My next smallest number is going to be, or my next smallest exponent would be 0. I'm going to just write it in the terms it was given to me as. And then finally, the last one, or the largest number, is the exponent of 2. So that is from least to greatest. If you have two numbers with the exact same exponent, that's when you start to compare the number in front to see which one is bigger and which one is smaller. So this is what it means to be scientific notation. The first factor, right here, has to be greater than or equal to 1 and less than 10. 6.92 is between 1 and 10. Okay? Another way of saying this, you have to have one natural number to the left of the decimal. It cannot be 0. So you have to have one number to the left of the decimal. So that first factor between 1 and 10. Then it has to be times 10. It must be times 10 to an integer exponent. It can be any integer. It just cannot be a fraction or a decimal. It has to be an integer. Those three things are what make up a number in scientific notation. So we start with something called standard form here, and here's the number in standard form. This is that number represented in scientific notation. The first number is between 1 and 10. It's times 10 to an integer exponent. That is scientific notation. So let's determine, of all of these numbers, which ones are in scientific notation, and if they are not, we are going to explain. So the first thing we look for, that first factor, has to be between 1 and 10. 20 is not. So we are going to say first factor is not between 1 and 10. This means between 1 and 10. It means x is greater than or equal to 1 and less than 10. So that's not scientific notation. First factor is between 1 and 10, check. It is times 10 to an integer exponent. This is in scientific notation. The next number, the factor is between 1 and 10, but it is not, times 10 to an integer exponent. Therefore, it is not scientific notation. Right here, first factor is not between 1 and 10. It is 10, but remember, we can, if we put a decimal point, our decimal point would be here. We can only have one number to the left, and here we have 2. So my first factor is not between 1 and 10, so I'll just copy that, paste it here. First factor is not between 1 and 10. Next, first factor between 1 and 10, check. Times, it is not times 10, it's times 2 to the power of 10, which is not times 10 to a power of an integer. So this is not scientific notation because it is not times 10. See that times 2? Don't let that times 2 fool you. Not scientific notation. Next, first term is between 1 and 10. Check. It is times 10. Even though 120 is a large number, it is an integer exponent. So therefore, this is scientific notation. 7.5 is between 1 and 10. It is times 10. 0 is an integer to an integer exponent. That is also scientific notation. The last one, that first factor again, is not between 1 and 10. So our first factor is not between 1 and 10. 0.5 is less than 1. So which of these numbers are not expressed in scientific notation? If they are not, explain. So, number 1. 1.7 is between 1 and 10. Check. It is times 10 to an integer exponent. This is scientific notation. Check. First term right there is not between 1 and 10. First factor is not between 1 and 10. So therefore, number 2 is not in scientific notation. Number 3, first term, is between 1 and 10. It is times 10 to an integer exponent. That is scientific notation. Check. So the only one that is not scientific notation is number 2. Now, depending on what calculator you use, now this is simply just to help you out. If you're using the TI-30s that we asked you to buy with the supply list, or ones that you had from previous years, awesome. Okay, this will not apply to you unless you start using a smaller calculator or a different calculator that does not have scientific functions. So sometimes you will type in numbers, and that's a great way to start comparing numbers, is to type in what's going on. But you're going to get these incredibly large numbers, and your calculator might give you something that looks like this with the E. The only thing that E stands for is exponent. So this first term right there, let's take the second number. Let's make that -7, not -17. So let's go with the second one that we just changed to a -7. This here, this E stands for exponent, so our exponent is going to be -7. So if we're looking to put this in scientific notation, that's what this should look like. And if we do what it says to do in our box on the right, if you were to do this in one of those calculators, that is what you'll get. So if you use a smaller calculator and you get 5.2 and it says e to the -7, after dividing this, that's what matches up. This top one right here, our exponent, if you were to do this in a calculator, would be 15. Again, Right here, this just tells you 5.2 times 10 to the exponent of 15. This next one right here, if you were to divide that in a calculator and you get this answer right here, that is this number times 10 to the negative 10th. Remember, the E tells you the exponent is negative 10 in scientific notation. And then our last one, if you were to plug that into a calculator and you get this as your answer, that means 5.2 times 10 to the positive 17th. This is to help you out with all different types of calculators.